I'm a member of the Jumpstarters team. This is our game. It's a action racing game with a twist, and we'll talk more about that later. But first off, we want to introduce ourselves. So, Aaron, you want to start us off with the artists?
Yeah, I just want to make sure that they're getting sound first. I think some people are saying they're not getting audio in the chat.
Uh,
Yeah.
well, there's no audio in the presentation.
Yeah. So there was a streaming audio problem right at the beginning. I think it should be fixed. Yeah. So I can perhaps I should go ahead and repeat the beginning bit since we missed that, but the people online missed it. So this is the first of our four teams. We'll have about 15 minutes of presentation from them, followed by questions in the chat, which I will repeat for the students so it can show up in the recording. And if they don't have their YouTube up, they can follow along as well. And then we'll move on to the next team. So we have four teams tonight, and the first one here is Jumpstarters. Take it away.
All right.
Again.
Yeah. So hello everyone. I'm a member of the Jumpstarters team. This is the game we worked on. It's a racing game with a little bit of spice added to it, but we're going to talk a little bit more about that later. So first off, we're going to introduce ourselves. We'll start with the artists. Aaron, you want to start us off?
So hi, I'm Aaron. I am the original brainstorm pitcher for this project, and I did most of the 3D modeling and concept art for this project, design lead.
And Julia?
Hi, I'm Julia. I was the art lead, and I primarily did concept art for the cars and also did 3D modeling for environment assets.
And Phoebe, are you here?
Yeah, and I'm Phoebe. I worked on the background art for the different environments.
Cool. Now going forward to programmers, my name is Joseph Robinson. I was the programming lead for this project, mostly working on gameplay and systems, but also a little bit of everything in between. Mike?
Yeah, so I am Mike Coakley. I'm the producer for our game, as well as I am a programmer. I worked on the AI this semester for the game.
I am Zachary Rosenberg. I'm also a programmer. I worked on implementing a lot of the sound into the game and gathering it along with doing some of the obstacles.
My name is Cade Christensen, and I am the HUD/UI designer.
And we also received additional help from Marissa Clayton. She did the graphic design, and from Winepot, who produced the music and certain fanfares.
Yep. So that's that. So Aaron, you want to start off talking about what our game's all about?
So I am a big fan of Speed Racer and F-Zero. When we were all pitching ideas, I thought I want to make a racing game, and I love the idea of just like cars that can jump over other cars and cross over obstacles and attack each other. So I pitched that, and here we are. We can use the jump to take shortcuts, jump over obstacles, and make sure like the lap times kind of like whittle that down. And we also have like standard nitrous boosts from like the typical racing game. You can just go faster whenever you use that, and you can also switch between drifting tires and regular grip tires. So the different programs I used this semester for this project, mostly modeling in Maya, and we did some modeling in Blender just to fix the car model. And for the 2D textures, we used Photoshop and Clip Studio Paint. And here's some concept art from throughout the semester.
All right, so going on with the programming of the game, this game was built using Unreal Engine 4. We did programming in both C++ and Blueprint. Blueprint was mostly used for things like the UI, whereas some of the gameplay aspects, mostly relating to like our car pawn and things like that, were done with C++. And our game's targeted system is Windows PCs, but we wanted to allow extra accessibility using gamepad input so that players don't feel like they're stuck using a mouse and keyboard, because that can sometimes feel janky playing racing games with that. And to explain some of the car types in our game, those are what really make it shine. So first off, at the top we have the spring car, and that one is it does a basic jump, but out of all of the types, it is the one that's able to jump the highest, the most force. So that can definitely be helpful in certain situations. And after that, we've got the rocket booster in the middle. You can see the little flames coming out of the bottom of it. This one jumps to the lowest force. However, it does allow double jumping, so it can definitely be more maneuverable in midair than some of the others. And lastly, we have the Jax type, which allows the player to jump left and right in addition to up and down. And that's with the medium force, so it's kind of like between the two. So for some other gameplay paradigms, some things we already talked about were like the mid-game tire switching. So players can choose between whether they want to grip or drift. There are some benefits to drifting that can be accessed by doing that. You can gain energy as you're drifting along. The higher your drift angle, the more energy you gain, and it also increases your speed as you're drifting. So there are some advantages to that over normal grip. And then shortcuts, like the one that's shown in the middle picture here, are kind of essential to some of our tracks. And they allow you to really exploit the track and cut down your lap times to get that really quick lap. Other than that, we've got the more traditional boost method, which just allows you to use a nitrous boost that increases your acceleration. Aaron,
Yes,
did you want to talk about this?
I just kind of wanted to showcase the process a little bit. The first image is just a gameplay mockup that I created as I was pitching the game. And you can see how it transitioned from that to the middle shot of, I think, really early on with our gameplay. And that was when we just had the second jump in an early version of our first track. And then the last image is a screenshot from our most current build of the game. So we've really made a lot of progress, and I think it's looking very good. And I'm excited to show everybody the work we've done this semester.
You can play our game. That's kind of what we're getting at here. Our game is set up to be played on Windows PCs. You can use the different input types, like we were talking about, keyboard and controller. And here's just some of the key bindings. They can also be found in game, either accessed from the pause menu or from the main menu. And so now we'll proceed with a gameplay demo to show off what it's all about. So here we go, starting up the application. Adjust about
maybe there. A little louder would be good.
A little louder, okay. I think that should be good. All right. So this is the main menu screen. We've got our credits here, obviously, just to let everyone know what we've done. I'm gonna start off by playing on the city track, and I'm gonna use a gamepad first off, just to show that that's possible. So First off, I'm going to select a level background. I like this one because it kind of goes with the buildings. And then here's where you can select your car type. And if you keep clicking on them, you can choose the color. And it changes the color of your car. So first off, I'm going to start with a spring type car. And we're just going to do a regular 3-lap race. So here, this is just basically starting off. I'm going to kind of explain the features as we go along. I'm just going to do like a normal lap first. So this is the normal grip mode that we were talking about. You can use the boost to accelerate, and there's jumps that you go over, things like that. And you can jump your car over obstacles like this, using either 2 jump buttons at a time or a specific like 1 jump key binding. And then there's the drift tire mode, which allows you to drift around corners easily. Things like the boost pads that you just saw. We've got our music playing in the background. That has been really interesting.
Music, we got it so on each lap, the instrumentation progresses. So you kind of get that sense of like you're making it through. Also, energy pickups.
I'm going to show off a little shortcut here. So this is the shortcut on the building track. It just allows you to basically bypass most of the track and hop back on at a later point, so you can get faster lap times like that. And then, of course, we've got our final lap. So let's try to bust this out as quick as we can.
It was the best at playing the game since he's tested it the most. So,
I've had extensive experience.
What's your fastest time on this track?
Believe it or not, it's 38 seconds. But yeah, I guess I'm the best in the world right now. No need to brag or anything, but you know. And yeah. So that's basically what it looks like when it's over. So we're going to return to the main menu so we can show off our other track as well. So here is the island track. We're going to do a lap of different car types so we can show off different things. Again, just a finite race. Start off here, and so this is the Jax type car, and here's a shortcut up here. I'm gonna jump right onto the track just so you can see the different animations and stuff that we've got in to really enhance the gameplay and show what's going on. There's a lot more on this track. It's a longer one, so that's why we're only going to do 1 lap. But there's lots of really cool obstacles and stuff along the way that we think makes the gameplay pretty fun, enjoyable.
Try to use the obstacles in ways that would make the player think a little bit more about when they would use jumps, drifting, and boosting.
Yeah, pretty much. And there's advantages and disadvantages at all times, but yeah, the freedom of choice.
Some places where
really helps.
Yeah, certain jumps would be really useful. The Jax jump in particular is very good for mobility or maneuverability, especially going left and right. It's just cool. But I've definitely used it to like cut that corner right there, and it was really cool looking.
Yeah, that can really come in handy in certain situations.
So I'm going to jump in early with a question from our guest. Katie asks, are there any other cars in the race? I know you were going to talk about that a little bit.
Oh yeah. So we had originally planned AI. Mike, do you want to talk some more about that?
Yeah, so we did end up designing an AI, and it did drive. However, we decided not to add it into the game completely because there was just a lot of tweaking, and we didn't necessarily have enough time to get something fully functioning. And there's nothing gamers hate worse than adding incomplete features to a published game.
Pick
Yeah.
the blooper this time, Joe.
I think you put it pretty well. So
Yeah.
and now I'm gonna do a rocket type car, so I can show that double jump off as well. Alright, let's just head around our track here. As the straightaway was a bunch of different obstacles. We tried to make it so that there's paths that you can go through if you know what you're doing or what you're looking for, but the main priority is to be able to jump over them, since jumping actually helps you. It gives you speed in this game, so it's kind of an incentive to jump to increase your speed as you're going along. So that was a double jump I just did right there. Up ahead a little bit, I'm going to show a situation where it might be even more beneficial to use.
Questions. What was the feature that made it into the game that was the most difficult to add? I wouldn't say feature, but I think getting the car model itself into the game was pretty hard.
Yeah, I don't know why that ended up being unnecessarily difficult, but after many hours working on it, we were able to get that in.
An all-nighter to put that in.
Yeah.
But once we got the car, and I felt like smooth sailing.
Pretty much. It was kind of just a matter of knowing it, because it wasn't something we had ever done before. So once you do it, it's like, you know, you've got it locked in.
And then we have another question: is did we ever consider making it multiplayer?
We did.
We did consider making it multiplayer. We were thinking that would be an interesting concept to go with. None of us had had a ton of experience in networking, and that was the main issue with that. We probably could have gone that route, but I think the game would have lacked a lot of the features that it currently has in it, and it would have been less enjoyable overall.
Another question: what was the design process for the tracks given the different cars and abilities? Well, so I did the designs for the tracks, and I tried to keep in mind all three different types of jumps and where a player could use them. So, for example, this jump right here, I had the Jack's jump in mind, just because it would look cool and it would feel more natural flipping between the two levels of tracks. And the obstacle placements and boost placements as well, that kept the jumps in mind, especially the rocket boost, just for more beginner players as kind of like leverage to help them control the car a little better in midair.
Next question is: how much of being good at the game is skill-based versus puzzle solving, knowing in advance when to switch tires or flip tracks, etc.?
That's a good question. I think it takes time to learn things like that. So going into corners, it's usually best to start drifting, at least if you're using things like your boost and stuff like that. As you play along, you kind of discover little gameplay strategies that'll help you increase your skill level of the game. There's lots of things like talking about the drifting, that helps you gain back energy. So when you're dealing with that, you're using boost a lot. You want to make sure that you're gaining that stuff back so you can use it later on.
And the reason we had Joe play test it is because he's the best. If you wanted to see me crash into some walls, I mean, we can do that too.
Yep.
It's like originally you kind of get the layout of the track and then you build the skills to get the fastest time on each lap. So it's definitely puzzle solving in the beginning and then skill.
All right,
I
next
think we've
question.
shown off most of the gameplay, but if there's still questions, we'll keep answering them. While I keep
Next
going.
question is, you have multiple playable cars, so were you able to establish a tech pipeline to get from design to playable in-game?
Yeah, that was so for the multiple cars that we have, there's two of them that are different textures and things, and we had to establish a pipeline to sort of get those in together. We ended up just being able to use the same skeleton and making sure that everything is set properly so that we could do that. But we were able to get the two different texture types in, and then with those we just did recolors for putting like different color cars in the game from just those two textures.
In the future, we wanted to add more models of different cars.
Yeah.
Then
That'll
we have,
be another thing
where
that
did we
we're
learn
working on.
Unreal stuff?
Where did we learn Unreal stuff? Well, I learned a lot of it from Mark Olano here. He teaches graphics for games at UMBC, so that was a good source for getting into Unreal and learning more about coding C++ and Blueprint and how they work together. But also things like game projects helped, working on different things in your own time.
I learned as we went along this semester, and that is why I am now registered for Mark Olano's graphics for games for next semester, so that way I can really like get a more professional learning.
Yeah, tutorials too.
Yeah.
I ran into an issue when playing it after crashing into Walmart. I wasn't sure which way was forward until I saw the upstairs. Any thoughts on player help? That is a problem we have been thinking about for a while. And there are a lot of different solutions. One could be an arrow pointing in which direction you have to go in. One could be the camera staying in the same place, but with the way we have the camera, it's locked to the back of the car. But with our physics engine, we weren't sure how to really fix this aside from with the player knowing where to go beforehand. Trying to keep it as simple as possible to eventually figure out the correct direction to go in.
Yep.
That is something I do want to work on, accessibility.
This next question's for you, Aaron.
Yes, all of the artwork is original. Phoebe did all of the backgrounds. Julia did the signs and obstacles. I did the cars, background models like the buildings and islands, and the tracks. Alongside the graphic design, which my girlfriend Marissa did.
And how hard was it to get the well-behaved physics?
It was definitely a difficult problem because there's so many different contributing factors, especially when you're working with like a racing game. There's lots of tiny details that can go into tweaking the gameplay elements. Like for example, gravity. I think right now it's like 3 times what humans normally experience. So, but it looks normal. So there's lots of details like that we had to look into during the development process that sort of shaped the way that our game plays now, and it's come a long way.
What is the biggest challenge you had to face related to making the game during COVID? How do you think you would have handled their issue differently under normal times? Honestly, for me personally, I felt like COVID helped me with this project specifically because
you weren't stuck on campus.
Yeah, just having access to my computer at all times kind of forced me to work on it, and not having like extra on-campus things, having to go to campus and back. You know,
I think that's a good point.
A lot of it streamlined the project for me at least, and I learned a lot about game development through making this game alone.
Yeah, I probably would have been sitting in the library on my laptop working on this, so I think I've definitely had a better setup at home.
Definitely.
Thankfully, Discord and Professor Olano made it like really easy to communicate with everybody.
All right, let's take one more question. Let's take David's question about the project management style.
Mhm.
Did you use a particular management style, Agile, Kanban, Waterfall, etc.? And did you think there were any benefits or drawbacks to using that?
Yeah, so we used an Agile style. I guess it was sort of Scrum-esque, as like every game development thing is. But yeah, we went through multiple development sprints, and some sort of like review processes we did with the class, and also just as a group by ourselves. So there were multiple like software engineering elements like that, just management things that had definitely gone into the process of this game. Is that it?
Yeah, okay. So thanks to the Jumpstarters team. Why don't we get the recurring moment team turn on your cams and set your screen sharing, and Jumpstarters, you can turn off your cams and we can switch on over.
Alrighty, can you hear me?
Yeah, I can hear you.
Beautiful. All right, cool. So this is the Recurring Moment project. I am Christian Mishka, the design lead and one of the programmers on the team. And back at the beginning of the semester, this was the idea that I came up with, and this was the elevator pitch that we had. So it's a 2D puzzle platformer that uses time travel mechanics inspired by the movie Primer. You enter a box at one moment of time and exit at a previous moment. So as I mentioned, we got inspiration from this movie Primer, which has time travel and scientists figuring out some mysteries going on there. Also got inspiration from this Flash game called 5X Man, and then some puzzle elements from the Portal series. This was the original concept artboard that Mark and I worked on during the first week of prototyping. In the lower left-hand corner, you're going to see the kind of toon look that we were going for. You also see some of the theme and the colors that we went for, and some inspiration for different ways the time machine could look. And Mark and Jacob will talk a bit more about the process of how the time machine changed over the course, over the course of the project. But I'm going to talk a little bit about the mechanics. You're going to get to see them in the demo at the end. And if you've ever watched the movie Primer, you've probably gone online and seen this very diagram, which I'll explain right now. So you see the blue timeline, which is the original player going through the level and doing their things. So they'll turn on the time machine, do some setup in the level, and then return to that time machine and spawn as that green timeline. And there's an overlap period there where your past self can interact with your current self as you solve the puzzle elements of the level. So this is the kind of the game loop that occurs. You solve multiple levels using this time machine mechanic. And I'm going to show the proof of concept that we came up with in the first week. So here we'll have a player going to the machine, going to the button, returning to the machine, and then you'll see both players at the same time. And this was just that original proof of concept in the first week of class that showed that it works. And then, oops, let me get out of that. And then on the right side, oops, let me make sure that's full screen. On the right side of the screen, you'll see the what we had at the end of the prototype. So we had a few more art assets, some animations going on in there as well. And because we're dealing with time travel, we need to store that in code somehow. So I'm just going to talk about the time travel data structure that we used. So you'll see here a spreadsheet, and this is actually one of the debug spreadsheets that we generate from one of the levels after you've played through. So the data is stored in a dictionary of timelines, where timelines are sparse lists that propagate the values into the future. And what's nice about this sparseness of the data structure is when we're going in the past and modifying things that will end up changing in the future, it automatically updates. We don't have to change every single cell. We just need to change the one, and then it will propagate forward. So that's a little bit about that data structure. If you have questions about that at the end, feel free to ask. I'm going to pass the mic off to Mark, who's the art lead.
Hi, I'm Mark Medina, and I worked as the art lead in Recurring Moment, and I basically mainly handled the character design, the animations of said character, and some of the backgrounds and the midgrounds that you'll be seeing with the parallax effect once we start the demo portion of this presentation. So one thing that I kept consistent coming from the artboard that was shown earlier in this presentation is this muted color palette of reds, greens, and blues. And if you go to the next slide, you'll see it's just the stages that that we went through with designing the main elements. With the first one being the player character and the second one being the time machine. So basically, I came up with the concept that the player character is someone who works at this facility / laboratory that makes said time machines, and you due to some circumstances, you have to go through all these trials in this facility. You see on the top some of the concepts that I created with like the present self and how the past self will look like, some concepts of like the time machine. And once I came up with these, I combined them with the artboard concepts with the outfit and the time machine. So you'll see on the bottom left, you'll see like a more refined concept of the player character. And then once we settled on that, we went with some of like the rough frames for the animation, hand drawn also, by the way. Yeah, so then we take these frames, and we also took the initial time machine concept, and I actually passed it down to Jacob to refine the design, match it up with current art style, make it more unified. And Jacob, if you could talk about that, that'd be great.
Yeah, sure. Thank you, Mark. So hi there, everyone. I'm Jacob Yepes. I was the producer as well as the artist. And as a producer, part of this was keeping track of everything in timelines and ironically timelines and deadlines, that is to say, and making sure everything was coming along during our sprint, because we were working with more of a agile and Scrum development system. But primarily my main job was as an artist. And as Mark said, it was a matter of taking a lot of his rough concepts and passing them on and finalizing them and fixing them up to look more in line with an art style that Christian, Mark, and I had all discussed on what we wanted to achieve. So we wanted something with thicker outlines. We wanted something with this very specific palette, looking back on Christian's artboard. And when it came to the time machine, which was one of the most important parts of it, we went through a few phases of it. You saw some of Mark's previous concepts, which I then took into something to deliver more of a steady, kind of firmer kind of design language. So instead of this lamp design, I drew upon my own kind of time travel media influences and inspired by works like Bill and Ted and Doctor Who, working with something like a phone booth, something that a player walks into and then steps out of. So we went from taking some of the design elements of the prototype, which I then developed into a paper sketch, which I then went into Photoshop and did a digital drawing of, which then after some discussion, we finalized into one that we can animate and work with in Engine. And I also used Photoshop to fix up many of Mark's animations, making sure that they're cohesive with the art style. And in the next slide, you can see some of the other examples that I had, such as props like the boxes and a later version of the time machine that we'll be showcasing in the demo. But along with these more props and environmental objects, there was also the matter of the heads-up display. which was also a similar streamline of getting the rough sketch into a prototype sort of form to implement into the engine, and then eventually a finalized form, which was implemented in by Wilson Fang, who was another program of ours who will unfortunately not be joining us. But his work was also extremely pivotal in making sure that everything was polished, unique, and he did a fantastic job with implementing in the heads-up display information, which includes the timer, a level indicator, as well as a little inventory section. But another one of the programmers who did a great job with implementing Mark and I's work into the level was the character animations, which were handled by the next member of our team, Aiden. So I'll hand that over to you, Aiden.
Thank you, Jacob. Hello, my name is Aiden Newell. I was the programmer lead on Recurring Moment, and some of the work I did on this game was work with our universal rendering pipeline, so the lighting and the shaders, and then the sound effects and integrating some of the music that you're going to hear, and the player and door animation. So if you could move to the next slide. Thank you. So the shaders, personally, was my favorite part of this project. So we downloaded and used the universal rendering pipeline, which is just a Unity package that takes care of a whole bunch of nitty-gritty rendering specifics. And we made the shaders in the shader graph tool with the end goal that we wanted a VHS kind of rewind static effect, both over the entire level while the player is rewinding, and then also applied two sprites that are back in time to kind of give that skittery, uncanny valley kind of intuitive depiction of what's in the past and what's in the present. So you can move ahead to the next slide. And then we also have lighting. So unfortunately, we were not able to take advantage of Unity's 2D lighting system that comes inbuilt with the universal rendering pipeline, because it had an incompatible render feature for our post-process rewind effect. And that is what we wanted more than lighting. So we had to sacrifice here, and we're just using Unity 3D light sources kind of at the right points outside of the 2D scene to create these illumination effects in the game. And that's it for rendering. So now I'm going to hand it off to Aaron to talk a little bit about the work that he did.
So I'm Aaron Griffin, programmer with Recurring Moment. The majority of my work was done programming the AI for the guard that you'll see later in the demo. So like right here we see it. Unfortunately, I was not able to get an animated version because I just didn't know how, unfortunately. It starts off walking left and right. For most of the early development, it was just like this. Then later on, it was added a state where it will see the player and will alert the player that it has seen them. And then after a few seconds, it will shoot you. Earlier on, what the guard shot was just a small circular bullet, but after some playtesting and feedback, it was changed to a hit scan laser. So it makes it more important to get out of the guard's range in time. I think that's about it for me.
All right, and we also want to give a huge shout out to my friend Jamie Curry, who was willing to create and custom produce the soundtracks for this game. So just give him a round of applause. So we're going to move on to the demo. Let me just switch my screen to get that up. Okay. All right, so you should be seeing my screen and hearing some of the sound that is happening in the game. I'm going to show off some specific levels to show off different features. So here's the first level that you enter, and you encounter the time machine, and this is where the player learns how to use it. And you'll see on the whiteboard on the left the different states that it can go through, and I can fast forward as well. Go into the time machine, and you'll see it rewinds, and my past player is there standing on the button for me to walk through. And that is kind of the basics of the time travel mechanic. You'll see the box that Jacob had mentioned earlier. And this button here, you actually need 2 objects to stand on it at the same time to activate it. So I'll just stand here next to the button and press it, and then I can travel back and go through here. I'll be standing on it. I'm on a debug build right now, so I can skip to specific levels to show you certain features. So I'm going to skip to this level, which is actually one of my favorite levels, because I originally designed this level with one way to solve it, but there are actually about 5 different ways to solve it after we found that out through playtesting. So I'm going to show you the original way that I intended the level to be solved. I'm also going to show you one of the features that is interesting with time travel. So I'll just skip ahead here so I can stand on this button. I can use the time on the displays to make sure I get my player back in time. All right. And then go into this second time machine. All right, I'll just skip ahead. Here, I'll steal that box, and you'll see the door close. And if I just sit around a little bit, then we'll notice that at about 30 seconds, my second player down there is going to walk back, but he's unable to walk back because the door is closed. So that's a time anomaly, and it breaks the symmetry of the level, and that's terminology that was used in Primer. So I can just respawn and try from where I last time traveled, and do it, and make sure I'm quick enough so I don't have that anomaly occur. I can just skip through the level, and like that. I'm going to skip to level 10 to show off the guard. So the guard will turn around and he'll notice me and he'll shoot me, and that is what happens there. I have this explosive, so I can blow him up like that, and solve this level like normal, without any deterrence. Okay, I want to show off level 14, which has a very interesting mechanic. So I'm going to put this time machine, or put this box up here. I'll actually stand next to it and I'll explain that in a minute. And then I'm going to pick the box up and bring it inside the time machine with me. And as you know, players duplicate when they go back in time, and so do objects. So now there are 2 boxes. I can blow up my past self, and that's going to cause an issue because this time machine is still running. And if I go to, I think it was like 28 seconds, we're going to get an error actually. That is not what I'm supposed to get. I'm going to restart this level. So it looks like there's 1 bug currently. That is actually supposed to show an anomaly on the screen, and it looks like that is not happening. So I'm not entirely sure what's going on there. Things happen. Okay, but I will solve this level. So we duplicate the box, and then go back here, and now I can explode both parts of the destructible platform, and I can allow my third self to get through the door.
You know, while we're talking about all these levels you're going through, someone in the YouTube chat asked, how many levels are there in the game? How many did you build so far?
Yep, so that's a great question. We currently have 16 levels, and I'm going to the last one right now. So we have 16 levels, and there's kind of a progression of different mechanics that are built up across them, and they all kind of combine as you go. In this level, it's very interesting. You have a foldable time machine that you can pick up and place down, just like you pick up other objects. And what you can imagine, you get some interesting things going on here if I skip ahead and I take this back in time with me. So we now have as many time machines as we want, theoretically. And I can use this to my advantage to solve this level. I only need to duplicate it once to solve this level, but you could imagine doing it more times. Just didn't think that doing it more times would be enjoyable for the player. And this is actually the last level I'm specifically going to show. So we're willing to take questions if anyone has questions. So here are the 16 levels. You can see your best time on them and return to those different levels from the screen.
Yeah, so we got a question here. Someone says, I'm very interested in the timeline's data structure. What performance implications or trade-offs did you encounter as a result of it? Was its architecture ever revisited after the initial prototype?
Sure. So actually, during the initial prototype, it was not as good of a structure as it is now. So originally, it was just like it was multiple dictionaries listed within one another, and then like a list containing all of the history of a certain variable. And that was very inefficient because you basically had these long lists, and the longer that you spent in the level, the more data would accrue in all of those lists for all of the variables. So that is why we wanted to go with that sparse structure, which saved a lot on performance. I don't actually have any specific numbers for performance that was saved, but you can imagine from like a data standpoint, instead of storing every single iteration throughout all of time, we're just storing specific points. It saves significantly.
Yeah, thank you. And there's a couple of concerns here about how players could technically just fill all of the fill the level up with all the time machines they could ever want. So there was a question here: is there a hard limit on the number of time machines you can drop in the level, and what's the best? Yeah. So is there a hard limit on the number of time machines you put in a level?
So there is no hard limit for the number of time machines in a level. The only case where you can have that duplication is when you have 2 time machines and at least one is a folding time machine. We only have a few levels that actually incorporate the folding time machine. So any other level that has the static stationary time machines don't have this issue. And I can kind of, while we're waiting for other questions, I can kind of cheese it and just create as many as I can here and see if we crash the game. So I'll skip ahead like 200 seconds before I finally pick this one up. So we can get the next question.
Yeah, so there was a question about regarding the timeline's data structure and the process involved with it. Joshua asks here, what's the best way you can think of to break that data structure, that kind of architecture, if I'm understanding the question right?
The best way to break it? That's a good question. So, I mean, I guess the best way, so because it's a sparse structure and we're dealing with inserting new data points and then it's filling in the gaps, the best way to break it would be to constantly be moving the player and constantly moving multiple objects on the scene so that you are filling up more of that structure than like individual points. Because when my character is just standing here, none of the variables for my player are changing. The only variables that are changing are the timers on these 2 time machines. So those are going to be the only ones that fill up in that structure. And actually, those aren't going to fill up because those are just a single point for when they started and when they ended. So that wasn't a good example. But like when my character's moving, any frames in between where he started moving and stopped moving, those are going to fill up in the structure. So if you could exploit it doing something like that, then that would be a way to do it.
Yeah, all right. And so there's another question here. Have you run user testing to see how straightforward the game is for new players to pick up?
Yes, so we actually had multiple people playtest the game. I personally had like 8 of my friends playtest it, and I know some of the other developers had their friends playtest it. We got feedback from them, incorporated that in our Scrum cycle to make it more playable. And we watched them play the game to figure out, oh, hey, these elements are not so opaque or clear, and we incorporated that into our development going forward.
Yeah, I mean, I know I can speak for some of when I was when I was having my friends playtest their questions about some of the mechanics and controls and how they work. And I know that led to us kind of having these little tutorial pop-up menus about what key to press to activate things. And just kind of other key introductory elements into the levels, such as the whiteboards that we had seen earlier. And so there's another question here. What was the process for designing levels and then ordering them?
Very good question. So I was the primary person who did the level design, and it was an interesting process. It wasn't something that I had originally envisioned at the beginning of the project. I was like, okay, well, it's a puzzle game. We're going to have levels. But I learned slowly that it was actually really fun to make these levels. And the first level, I'll just go to it. The first level that I made that I really thought about was this one. And this is the one I said that has multiple solutions. And basically the process of creating these levels was, okay, we have these different elements. We have the box, we have the time machines, we have the doors. How can we pull in one of these objects at a time to introduce it as a mechanic? And then how do we use that to create a puzzle? And that was the more interesting part, because it's like you have to think backwards to what the player's thinking, because it's like the player is solving the puzzle from the beginning, trying to figure out what to do to solve it. But as a level designer, you already kind of know the solution, and you have to try to restrict the number of ways that you can solve the level, so that they're using the mechanics that you want them to solve. So it was a very iterative process trying to get those things going. But yeah, it was fun. We started out, I think we had like 10 levels by the second sprint, and then we continued adding levels over time.
I'd also like to mention, is my mic working? Okay, I'd also like to mention that a lot of people had this as like their favorite level because it was just like a culmination of everything that they learned so far, including myself. I love this level, like when I first played it.
Yeah, and I'm going to show one of the solutions that someone came up with, and this was the least expected solution that I had, because you only need to use one time machine to do it.
Yeah, I tell you, when I was playtesting these, I'm not so good with puzzle games, so to make sure that elements worked, it was a little over my head. But there's another question here. Is there a way to tell which rewind instance goes with which time machine visually? And I can kind of speak on that a little bit, because this was sort of a concern we were having, especially as the camera starts to pan down, because originally it was a little closer to the players. So for instance, in this level 6 here, you could, I believe originally it was kind of just like you could see the top floor or you could see the bottom floor. The camera was a lot tighter. And so there was just some concerns with that, which is why we kind of wanted to implement this heads-up display, this kind of just this interface of which the user can keep track of particular time machines. And basically, as you can see, as you activate one, it'll pop a timer up on the UI, and that'll be A, and the second one that you activate will be B, and that's a way of sort of keeping track of the times that are left on each machine. And when it comes to the actual rewind kind of clone timelines, there's still some things that hopefully, if we were to develop this in the future, working with things such as tinting the machines and making the time machine clones tinted to match their respective machines, or kind of having these sort of particle trails as you're moving along to see what kind of things, when the clones kind of carry on through, what path they'll be taking.
All right. That seems like about a good place to stop for now, and we can transition over to our next team, which is Sword Shibe. So anyone on the recurring moment team, if you want to continue to answer some questions in the YouTube chat, you can do that. But let's move on to Sword Shibe. So recurring moment, turn off your video cams, and Sword Shibe, turn yours on, and we'll get going.
Okay. Hi, everyone. Our game is Sword Shibe. It features a bullet. Oops. It's a bullet hell game featuring a sword-wielding Shiba dog. We can go to the next slide. And then everyone, if you'd like to introduce yourselves.
Hello, so I'm Angeline Xiao, and I'm the one who pitched the idea of Sword Shibe. So I'm the lead designer of the team, and what I do most is animation and art.
Hello everyone, I'm Kuchung Tao. I'm lead programmer in this team, and what I do is to create the enemies AI and player system.
Hi everyone, my name is Maggie Paletti. I'm a programmer. I was the producer for this team, and what I did was implement some UI stuff, and I implemented an enemy or two, and some very bits and pieces of code.
Hello everyone, I'm Samuel Taman, programmer. I worked on mainly the level design, working with status effects on the player and fine-tuning the UI.
Hi, my name is Riley Maloney. I worked on generally the UI for the game and most of the menus.
And hi, my name is Zach. I am an artist. I'm the lead artist also. And I was responsible for doing a couple animations for some enemies, making some assets, including the tiling assets that build up the world. And I also made the music for the game. Next slide, please. So our game started off, wait, we went too far here. We got to go back to the intro. All right, there we go. Thank you. So our game started off as an idea from Angie about a bullet hell game featuring our lovely Shiba. And as we continued, we kind of we started with a Zelda type of progression system and idea for how the gameplay would feel. But as we kind of kept developing and moving on, we moved towards a procedurally generated dungeon crawler that evokes a gameplay style kind of similar to Hades, if you're familiar.
All right, so initially for our game, it has no base story or theme. But over the course of development, we moved towards a more Japanese theme, and it has an actual storyline. So the storyline in summary is Amaterasu, the goddess of the sun, was corrupted by curse of madness. So you play as a sword-wielding Shiba who is on his journey to rescue her. So you have to kind of move to go get her in the end. But along the way, there are enemies coming to stop you. So you have to slash your way, get to your destination. So at conception, the plan was we supposed to have pre-made levels, but we thought, but why we spice things up to have more randomly generated levels so that each run, the level was different. So everyone's run is never the same. And then, so over the course of our developments, the bullet hell aspect was partially fade out. That is to better balance out the game more.
Sword Shibe was, as Angie said, mostly inspired by traditional Japanese folklore and legends. For our enemies, most of our inspiration came from Japanese yokai, which are traditionally supernatural monsters, demons, spirits, things that would haunt the night and sort of existed to terrify people. So we thought that would be perfect for the enemies that you're fighting in the game. Everything else, portals, foodstuffs, as you can see in the bottom right, we took influence from Japanese cultures in general. So for example, you can see we used onigiri to make the foodstuff health item that we used to regain hearts. And it's a fun little Shiba Inu themed food. Next slide, please. So we have more examples of our concept art and inspiration. The most obvious being the kasobaka, which is the red umbrella in the top left. Just creatures that are typically malicious in Japanese culture, used to make the fun enemies that you fight against. They're all very unique. One piece of inspiration that we thought was particularly fitting is the moving image in the bottom middle is the komainu, which in Japanese culture is a dog lion statue guardian that will sit outside the gates of temples and sort of protect the inner inhabitants. So our final boss of the game, that guy who's screaming at the bottom, is the sort of the final gate before you are able to rescue Amaterasu.
So for the coding research, we modify some of the animation. We use an in-script state machine rather than the built-in one. So the animation for player and the enemies are tricky. Unity has a thing called the animation state machine for the animating game object. At first, it gives us the many bugs. So like the weird fade in, fade out when animation transaction, or the weird behavior when two animation happen at the same times. So instead of using the state machine, we create a script to fully control the animation. In the result, we replace the massive animation transaction links with a clean result.
Yeah, that made for a much nicer workflow for the animation. The characters tended to get choppy, and the same could be said about the enemies. When it comes to the room generation, we took the theories behind Prim's algorithm and Delaunay triangulation to map out where rooms would be laid out and the routes to go between rooms. Typically in that kind of setup, there's hallways that are developed in between each room. However, that portion of it was removed because of the bullet hell aspect. We figured having players in a small space with a lot of attacks coming at them at once wasn't the best idea. The generation of the tiles in each room was based on chapter in GPU Gems 2, where if you can see at the bottom right corner of the image there, each side of the tile is coordinated with a color. And we took inspiration from that theory and implemented that with the two-dimensional tiles that we used to have a nice changing layout to each room and each biome. And when it comes to object placement, although it's not shown in these slides we'll show you during the demo, object placement was done through a blue noise algorithm using Mitchell's best candidate. That way we don't have too many overlapping objects, too many overlapping enemies, anything that would be spawned inside the map.
All right, so for a project like this of this scale, it's quite hard to organize things and to figure out what the best options are for how to progress when working and building the game. So here's a few things that we did again, for organization and when building. We developed the game using the Unity engine because that engine is particularly good with two-dimensional games. It's quite simple. It's comparatively simple when looking at other game engines. We did version control using a GitHub repository. Both programmers and artists had to upload their work there. And then whenever like a programmer or artist would see there was an update, they would have to download the repository. And everyone was always able to be up to date. Because we wanted a hand-animated feeling, the animators chose to make enemy and player animations using Adobe Animate. But static assets like tiles, obstacles, and the skyboxes that you will see in our gameplay demo were made using Clip Studio and Procreate. So regarding our burn down chart, we worked on the game over multiple sprints and managed the assignments for the sprint using a burn down chart, of course. With an agile management style or a scrum style, it really helped us a lot to keep on track and hit our goals. So I guess we're going to start the gameplay demo now.
Yes, in 1 second.
There we go. Audio sounds good. So as you can see, here's our prologue introduction, and we have a nice menu overlay when you start the game to show you the controls. Nice little loading screen for our transition. Each loading screen is different. It'll show you kind of what you should expect in the next biome. Here you can see the blue noise algorithm at work with the enemies placed further away from the player to make sure that they aren't attacked as soon as they spawn. Objects are placed alongside the items that the player can collect. Those onigiri items will restore health. The sword items, if we can find one, will give you an attack boost. And these portals, you'll see there are grayish portals that teleport you room to room. And then here we have the red portal, which will teleport you into the challenge room to progress to the next biome. Kacheng, if you want to go ahead and hit the skills menu and showcase and showcase the skill system, we have level up gifts for you. So you can have you can gain more life, you can gain more attack speed, or you can
Yep.
There you go. You can gain a dash speed. Excuse me. The challenge room consists of multiple rounds. So once you finish defeating all of the enemies through each of the rounds, you will progress to the next biome. And now we're moving on to the snow biome. Each biome has its quirks. So the grass biome had more objects. The snow biome instead has this slow effect. So if you run through the darker patches of snow, you actually are slowed down, and it makes it harder to dodge enemy attacks. We also have, if you can see, it's kind of hard to see because of the color, but there's a particle system in the background that shows just some snowflakes falling, just to kind of give the nice aesthetic of the biome you're in. And Kasheng, since I know you're playing with keyboard, do you want to switch to your controller? We also have a controller scheme set up. That way, if you prefer to play with a controller instead,
So
we also have that map.
I'm playing with the controller now, so no cheating.
No cheating.
Yeah.
So now that he has the controller layout or controller plugged in, it does show the control scheme for that controller as well. There's our lovely pause menu. Kasheng, if you want to, you can explain the soul system.
So the soul system is like the bonus point for player. Like when you kill the more enemy, you get more soul and you get more damage. But once you get hit, you lose some health. You will lose your damage. So for now, you can see the right here. The right soul is the max soul you got. So, but once you get hit, you will lose some soul, and it will become like yellow and red and. I know yellow, green, then the blue is you don't have any souls.
This is minor, but I'll also say that I made the music for the different biomes, and it's basically the same track, but as you change through each biome, the instruments in the music slightly change to affect kind of the aura of the environment that you're in.
Mm-hmm. Now we hit the volcanic biome. So the trick with the volcanic biome is it has these fire pits. See if we can find, there's one. And if you run into it, you take damage. So you want to make sure you're not hitting those. Something to note about each biome is that the grass biome is kind of the medium-sized biome. The snow biome is smaller, but because of the slow effect, it's a bit more difficult to run through. The volcanic biome is massive. It's harder to run through. There's more enemies. It's generally just harder to find the exit to that final challenge room. In the demo build, there aren't as many enemies, or the presentation build that we have now. There's not as many enemies, but you can imagine multiplying that by a factor of about 3, you might get swarmed. And you can see our different enemies and how they act. The umbrella guy, or Kasobake, likes to run towards you and spin as an attack. Our Shirime, which Kasheng's catching before it hurts him, is the green little monster who transforms into a little tentacle eyeball who shoots lasers at you, shoots little bullets at you. And then we have the Tanuki. The Tanuki I find the most tedious because he loves to teleport around you and throw stuff at you. And as you can see, it is very hard to find that last exit.
Well, while you're looking for that, a couple of questions from the chat. One is the procedural generation seeded such that runs could be potentially shared and duplicated, which probably has something, some bearing on the search for the exit right now.
So the procedural algorithm, initially we did include a seed. However, the seed was removed more so to keep everything randomized. We didn't see a reason to keep the seed in for it, just because each playthrough was kind of a one-time thing. We kept it kind of similar to a roguelite aspect where it's a run and done. We had mechanics such as saving and retry systems that we wanted to implement, but we just didn't have the time for that. That is something that we look forward to introducing into the game to get more of a roguelike aspect into it.
So Josh also asked, did you roll your own Delaney triangulator, or did Unity have one?
We rolled our own. We did find some code for developing one, but I found it easier to work on it myself than try to implement somebody else's code. Because of the time constraints, we were deciding whether to keep the procedural algorithm. We were deciding to keep it among the sprints, and because of the deadlines, I found it easier to write it myself. But there are Unity ones.
Yeah, we have a comment from Scott that not having a seed could make debugging quite difficult sometimes.
That is true. Our workaround for debugging was actually to go each biome is its own scene, and our route of debugging was to drop in a player object, the player object, and run around that biome to debug any issues with it.
So Joel says, I love the enemy designs. Was there any thought of biome variances in their appearance or difficulty?
Yes, so actually, yeah, go ahead.
Sure. I was going to say, I'll start off with saying that we did make some alternate enemies and ideas for more enemies that are tailored to biomes. Like we did create more of like a, let's say let's start with the Ninja Tanuki. We had a additional version of the Ninja Tanuki that would throw out ice kunai knives that would initially slow you, but then we adapted to move the slowing mechanic specifically to the biome itself and less on the enemy.
As you can see here, Kasheng is now fighting the final boss. Good luck, Kasheng. Up and there he goes. Okay.
Well, you got some positive comments on the splash screen, the enemy design, especially the chasing umbrellas, and actually a couple of people commenting on the enemy design. So that part definitely came over
The
well.
enemies were very nice.
Yeah, Angie did a
I personally struggle with the Tanuki. Can we head back to the slides? And Angie, can you take it from here?
All right, so as you can see from our demo video, there were a lot of stuff. But initially we thought of even more ideas to make our game to have like a lot more cool content. But unfortunately, because of time constraints, we have to cut out a lot of it. So one of it is like, we initially thought of making more enemies. And one of those was like biome specific enemies. We also thought about having unique bosses on each biome at the end, but we swapped that out with challenge rooms, as you can see. We also thought about having saving systems so that every time you reach like a new biome, you kind of get a checkpoint in the beginning, so you can always go back, whether you quit the game or you died in that specific biome. So we also supposed to have more story details. In the end, the final boss is actually Amaterasu herself, but we couldn't implement a boss fight of her, so we just made the Komairu, just that large dude that we just fought now, as the final boss. And initially about the soul system that Kacheng talked about, it's so all the enemies that you defeated, you collect souls from them. And it's originally used for opening certain gates throughout the biome. But we changed that to like having your attack higher based on like how much you kill and if you're not hit before. And the last two are viewable maps on each biome. They'll be showing on the corner. It's not in. And we also plan to have more attacks for Shibe, like having magic attacks from certain items you collect throughout the map. So yeah, that's all the stuff that.
So there was a question, well, one comment, props for having the intro and outro sequences, and but a question, what was the process for developing the cutscenes?
I can answer that. So at first we were debating whether to have cutscenes with text, cutscenes without text, whether we wanted to make it fully in Unity or have a video that would play. So based on our current time constraints that we had, we made it so that our very talented artists made some assets that I animated in Adobe After Effects, exported them to videos, and then I worked with our programmer, Kasheng, to implement them into Unity.
And do you feel you were successful in unifying the art design between the bio backgrounds and the enemies?
I would say if we had more time, we could come up with a better unifying style. I think what helped us a lot was we animated all of the enemies in Flash specifically, or Adobe Animate, but that software has such a specific brush stroke and style to its animation that we realized that we should probably move all of the enemy animations to that program. I made the tiles mostly in that program when we started so that the line weights and styles would be consistent. For certain assets, I wanted to go a little fancier. Like for the challenge room, I wanted to make things that had more than what Flash can offer you for illustration, which is kind of limited. I wanted more brushes, but now looking back on it, I can see that it does kind of conflate with the style we've already set as standard.
All right. I think that's good for the questions for Sword Shibe. Why don't we go ahead and transition over to Tiny Tacticians. So the Tiny Tactician team can turn your video on, and the Sword Shibe team can turn your video off.
All right. Okay, you can hear me fine on here?
I can hear you. Can you hear me?
Yes. All right.
Working so far.
We are the group with the most technical difficulties. Oh, great. Hang on, I can't get to the Zoom present button.
Oh no.
PowerPoint's messing up my screen.
PowerPoint.
Hang on. I don't need sound on this. I'm just going to share the screen. Share.
Cool. It's up.
Wait, probably want to optimize for video screen, right?
Yeah.
Hang on, let me use share. Optimize for video clip. Share. All right. Please don't cry. Okay. We got everyone up here? Everyone good?
Julius, okay.
Yep. All right. So, if it's without further ado, this is Tiny Tacticians. It's a game about bugs. Hopefully not the type of bugs that break the game. Let's get into it. So, the dev team. I'm Anthony. I am the producer here, as well as behind a lot of the main programming on the project. And then we've got Brandon over here. He's my brother, as well as he has been doing the hard, nitty-gritty programming alongside the VFX and all the really nice things that make the game just work. We got Julius over here. Julius has been doing the most of the animations and the character animations and design is behind most of all the bug artwork. Then we got Sohei over here, who's been doing a bunch of the design and the UI work. All right, so what is this game? There's a lot of things I can call this game, but just to summarize it up, it's a turn-based strategy game that's kind of like checkers, but it's not. So you'll see what I mean when I get into it. This is a problem in modern turn-based strategy games. Nothing against Disgaea fans out there, but looking at all these numbers and all these stats, it's very complicated and confusing to even tell what is happening. Not everybody's willing to go that far to understand it, especially not young folks. So we want to make strategy games that are a lot easier to understand, something that everyone can play. But also, we're not going to make a really dumbed down strategy game. This has to have some real thinking to it, some real big brain power. We want to make it easy yet hard at the same time, which is always the middle of the ground, which is hard to get. But let's see where we got with it. So we started out, this idea of strategy game did not start out in bugs. It originally started out in clouds. We were doing cloud checkers, it was called. There was little cloud characters. That evolved when we got artists on team into hamster toaster checkers. And we were hamsters that had toasters on it inside of a little butter building. And they toasted around each other. And now that evolved into, once we got another artist on the team, into what you see now as our game with a bunch of bugs in a leafy environment. So I want to go over a couple of features in this game first. First thing is this is multiplayer. This is a multiplayer game across 2 clients, 2 phones, 2 computers, whatever you want to run it on. It's run on an Amazon EC2 server through Amazon Lightsail, very cheap server. Don't worry about that. But we do a particular way of running this in which the server is just used for matchmaking, and most of the communication is client to client. So we don't have to worry about our client server architecture, and allowed us to do some rapid multiplayer development. The art, there are 8 characters in this game, and each character has its own icon, its own animations and frames, and its own emoticon, which go with it. Also, each of these characters have their own abilities that are important to the game, but we'll get into it later. These are all the design work is done by Julius right here. So then the design elements of the game, alongside to complement those types of those cartoony bugs, we want to go for some simple yet bold colors and outlines. And since we're going with bugs, we also want to try to go with a more physical and natural UI element. Next, the music here. We don't have any musicians in the group, but we know a good website that has public domain music where this one dedicated guy makes a bunch of great public domain music. I absolutely recommend you check out this website. I cannot pronounce this name correctly to give credit here, but definitely check it out. It's used for the title screen and battle scene. Next, one thing I want to highlight of this game is it's the first game in the history of this class to be using the Godot engine, the Godot game engine. So far, our experience has been great, powerful, fast at everything we need to do. The biggest problems we ran into is when we wanted to get into nitty-gritty optimization and rendering. Then it became a searching game of battling the engine and some problems. But not to go too far into that, right now, let's talk about how the game even works. I told you it's a strategy game, but I didn't tell you what it actually you have to do. So I'll just show you a couple GIFs right here of what the game looks like all at the same time. Basically, what I want to show you here is you can jump over each one of your characters like checkers. You just jump over another piece to attack them. You can choose a lineup of 4 different bugs to start your team with, and you have special items that will increase your bug's power in many different ways. So another thing I want to show off here is this was optimized for mobile very, very painstakingly by Brandon here, and he can tell you more about it. But here's some videos of it playing on the phone in like 60 or so FPS, and it's absolutely amazing. These are very low-level hardware phones, not your easiest phone that you can come by, and not your most expensive phone, S10, S20. We got only old phones in this house, and it's running perfectly on them. So yeah, that's it right there. I am
just going to chime in. That white phone in the center, that's a phone I got for $30 5 years ago, and it still runs great on it.
So yes, you can run it on almost any cheap piece of Android hardware you can find on this market. But let's go to the next slide. All right, so how to play this game. It's a multiplayer game, so you have to go and find a player in the lobby. And then once you find a player in the lobby, a match is set up. So in that match, you take turns. Just all you have to do is tap on squares to move your units, your bugs, and you can move them like checker pieces. And if you just move it one space at a time, or if you run into an opponent, you jump over them and attack them. And the objective of the game is all you have to do is break into your opponent's goal. That is it. So you just have to reach one single space, and if you do, you win. But your opponent's also trying to do that. So it's not as easy as you think. So, but is that all? No, this is not just a reskin of checkers. Each of your bugs are unique. They each have a special skill gauge, which fills up every time they visit squares. And that skill gauge will get them berries, and those berries have unique abilities that can do anything from make your player jump all over the field to make your player invincible for a turn. Since you have different abilities associated with each berry, associated with each bug, you got to pick your team wisely and have a good team composition in order to win. There's even more? Yes. So this is another concept added in there. Not only that you can move your pieces across the board, you have only 4 pieces. And if one of your pieces dies, you kind of set back a lot. However, you mark territory in this game. You mark territory every time you visit a square with your color. And any square that you mark, now when you jump on it again, you have increased range from that square. So instead of moving 1 square at a time, you can move 2 squares at a time. So using that, when your player dies, it goes to the bench and respawns. And then once after a few turns, it goes to the bench, and after a few turns, it goes onto a respawn tile. And then using those colored squares, you can go faster back into action without, even if your field is empty, you might be able to make a comeback really fast. And again, this is heavily inspired by Splatoon. All right, I will put this next to Brandon to talk about optimizations, which has been a huge part of the game the last week or so.
Yeah, this has pretty much been my life for the last 48, 72, 96. I can't even count how many hours I've spent on it. That's more like optimizations. Okay, so can you go to the next slide? So this is a 2D game, right? It's got little 2D sprites. You're in a 2D scene. Oh, that shouldn't take anything. You're just putting a sprite in this. That's just like a 2D thing. I'll just render it like the same way, maybe translated it. Surely that's not going to take any sort of hardware. That's not what happened here. So when we first got the game running, even on my gaming computer, it was kind of struggling to run, which is really weird because this is a very, very simple game. So first tactic, like any game with sprites in it, let me toss it all into a sprite sheet. Hope it works. We did that. It only got like a few FPS, like maybe 1. It didn't do anything. It was crawling along at about 18, 20 FPS on an actual computer. It was awful. So just simply putting it in the sprite sheet wasn't our immediate solution here. Next slide. Doing a little more digging, I found out that just the act of outlining a character, putting a little blue outline, every one of those shaders that did that had to do 8 separate calls on that. And since it had to do 8 separate calls, that means like rendering 9 copies of the same texture across all the characters. Suddenly these little 800 by 800 texture lookups might triple, not triple, but we got like 8 times 9. We got 72 lookups for all the characters on the board, every frame. That's not that good. So first idea is let's bake that texture. You see on the left, there's a bunch of white and colored. Basically, we'd make a fake outline by taking the old picture, processing it in a tool like GIMP or Photoshop to make an actual outline, and then take the 2 sprites, combine them, and you get the outline sprite. The reason why I took this approach is because you can just modulate that other sprite, and it would be picked up by batching, and batching would render everything in one draw call. But that's not quite how everything turned out. It wasn't all magic. So next slide. So yeah, eventually I was able to get them all rendered in one 2D draw call. But when you have all of these sprites, all of these 800 by 800 sprites in one file that's loaded in at once, I got 500 megabytes of VRAM and would crash my tablet every time I was trying to play it. I got one draw call though in 2D, so surely something must be optimized, right? Turns out there's something even more going on. Can you peer to the next slide? Okay, so here's what happens. Godot, as nice as it is a open source engine, their workflow that they encourage really right now is very bad. They ask you to take a sprite, render it in 2D in a viewport, in a canvas layer. And then once you rendered it in 2D, take that already rendered thing and then render it again in 3D. Rendering in, that's a whole another slowdown because you now have the 3D renderer waiting on the 2D renderer, and you're wasting all this time waiting between the 2 renderers. So instead of doing that, how about we just make it directly render in 3D? How do we do that? We cheat by making fake 3D sprites. If you're wondering why I have to go through all this nonsense, it's because that shader that was expensive isn't actually available in Godot for 3D. Actually, no 3D shaders are available on animated textures, making this a lot harder. Could you go to the next slide? So took one little sprite like that. You can see it looks perfectly normal from the front. But if you look on the right texture, it's actually 4 different textures layered on top of each other in 3D. But we're using an orthogonal view, so no one's going to know the difference. It's always going to appear like the left texture. But doing so allows us to skip the render in 2D, render it directly in 3D, forget all the crazy canvas layer viewport nonsense, and go directly to the 3D pipeline. This actually dramatically sped up the processing power because it just works with the render. Can you go to the next slide? So that got me a nice chunk of 10 FPS. Another thing is we had a nice little background that had all these trees. We spent quite a bit of time making it, making sure it was the right size, right proportions. My artist can really testify how many times I'm like, no, resize it bigger, smaller, put the height here. We spent a lot of time on that, but turns out that having a sprite map in the skybox is super expensive because every little ray of light is, even if it's indirect light, if it's got any sort of reflective surface, it has to go all the way out to that texture and look it up. So that alone cost another 10 FPS slowdown to a rendering pipeline. Cutting that out and just using a clear texture, we're not even going to look at the skybox anyway, so we don't need it. It sped us up incredibly. Next slide. So after this, we got to a point where a Kindle Fire was doing about 35 to 40 FPS. This wasn't annoying. It was pretty easy. It wasn't inconsistent. So we thought that was good, but I wasn't done yet. Next slide. So shadows, doing any sort of lighting and shadow rendering in any game, that takes some extra work because every shadow takes an extra draw call for everything that needs a shadow. So I'm like, how do I get rid of these shadows? How do I get rid of the shadow limitation? And just to show you how much of a slowdown this once caused, the basic sphere in Godot comes with like 30,000 vertices in it. And every character had that sphere so it could reflect the shadow in 2D. And that caused me to have over 600 to almost 1 million vertices first rendered when doing this. So yeah, there's huge slowdowns from these shadows. So how do we cheat it? Could you go to the next slide? So first thing I tried was just turning off the shadows. Instantly, I turned off the shadows and only used what I used. I got 60 FPS on the lowest of hardware, the Moto E2, which is more than 5 years old right now. It was a $30 phone. It shouldn't really run anything nowadays, but was running 60 FPS just great. So 60 FPS is fine and all, but no shadows kind of looks a little ugly. So we can trade off a few of those and instead pre-bake the shadows with a light map and get both amazing looking renders and 0 computation time. So can you go to the next slide? I want to see what's on there.
0 computation time.
Yeah, it's texture lookup time. You're not doing, you're not reflecting any rays.
That's right.
So after doing all those optimizations with the pre-baked light map, I also made fake shadows. I put because I had a directional shadow that would cast on every character, so you could tell better where it was located. I had to put a little sphere at every character. No, not sphere, but a circle at every character's foot. So it looked like they had a shadow. It looked like they were casting a shadow, but there's nothing that was processing it rather than just a mesh being there. So it looks like there's shadows, but there's no shadows in the game. But I'm getting fast results, great looking stuff, and it's great. Final step is now that I've got all this FPS, I can start going for post-processing. I found out that with very little effort, you can just use some emission materials and make a normal looking scene into a fancy, glowy, mysterious looking one by just really playing around with the shaders. Wouldn't be that expensive, but it doesn't help mobile that much. So that's something only we're considering for PC. But
I will note right now that we are only working in GLES 2.0 instead of 3.0 or Vulkan. So we are going on low hardware.
We're begging for crumbs here. Is that it?
All right. Yes, that is it. Now it's time for our live demo. I will stop sharing, and Brandon, you bring up the version of the game.
All right. Let me know if the audio works. Okay, so share sound, optimized for video clip, and show all windows. Please work. Can you see it?
Yes, I can.
Can you hear it?
No. Well,
wait,
there's no sound here.
What about now?
Yep, now I can hear it, and it's
Is it
at the
loud?
right volume. Good
Right
volume.
volume. Cool. Okay, so Ansel, you can take it away from here. I'll just play.
All right, so we have here our character selection screen. You guys select 4 different characters to choose your team. You can select multiple of the same or all different ones, however you choose. It's somewhat maybe not designed off of Smash Bros. Character selection screen here, but it's similar to other mobile games out there in the same genre. So your character selection affects what different abilities you have when you fill up those meters at the top screen, which you'll see shortly. But you can see at the top, it shows you what skilled abilities that you have per each character, such as the bee will warp you across the field. Ladybug will make you go 2 turns at a time. Stinkbug can block out a space at once. All right, I'm not sure if I should say every one of them, but all right. You want to select your characters right here?
Okay, I think I'm all set. Julius, do you have the game up and running on your end?
Yeah, I was gonna mute myself because the sound.
Cool.
All right, so this is our lobby here. It's again running on our Amazon EC2 instance. You can challenge a player. So Brand was just challenged right here, and it shows a little tutorial menu. You can go through it really quickly. It shows how to play in a couple of pictures, but that maybe a little updated, but it's good for now. There's our emote system. You can go and send an emote to the other player at any time, and it'll play a little effect right there. So as you can see right here, they're just taking turns, moving their characters up and down the map, just diagonally across squares, just like a checkerboard. You can rotate the camera. It's in an orthogonal view, but you can rotate around the field so you can see different angles, which is sometimes very important. We found that sometimes the camera blocked different things. You can also go through different zoom levels, which will go all the way to a top-down view. You can see another emote right there. Top-down view, or all the way back to a really far out third-person view. So the Brandon is in blue and Julius is in red right here as they keep taking their turns. And they are right now going and filling up those meters, which are at the top. And every time they exit a square, that powers up each one of those meters, as you can see with a little VFX to go into each one of them. Now, I believe, as you see, Brandon what's it called? He paired up his 2 units together, which allows you to move 2 units at the same time. But you can, when you move them at the same time, you can power up both their meters at the same time, as well as, you can unload them, unstack them at any point, which can be a very useful play in some defensive turns. All right, so you can see Julius just used the stink bug power up, which blocks that square out entirely. So Brandon cannot move past that square. All right, so it seems like both players have no berries right now on the field. You can see the berries or the skills at the bottom half of the screen. When a player obtains a berry just like that, it will go down at the bottom screen, and then that player can use that berry on their next turn or any following one. This is a web trap berry, which puts a trap down. That's a spider's special ability here. So it will put a trap down anywhere on the field. If a player goes into that trap, he or she will be stuck there for a matter of three turns. So it can be a bait to your opponent to fake them out into going into a square, or it can be a very good guard against a player who's about to break into your goal. So I see we got another one here. This is the Godot Cavo berry. So the Godot Cavo is gives you invincibility for 1 turn here, which is very useful again when either trying to guard or when trying to break into your opponent's base. I'm not sure when he's going to use it. He might save it for later, might not, but it's a very good to hold on to these berries as you keep going, because you never know when you might need it. So if you don't know which berries or what abilities your characters have, they're at the top screen where it says tap to see more. So you can view them anytime that you'd like. And while we're on the top screen, go through the options menu. We can also just adjust the volume and all that, just nice little options. We originally had, don't change the volume too high here.
Is that good?
Yeah, it's good, it's good. Good right there. So there we got that. Right now it is still Julius's turn. As you can see, the top screen is red. That means the opponent's turn. That's a very useful use of the emote right there. And
Jonathan on the chat asked if you had any consideration to protecting against an opponent spamming an emote as a means of harassing or distracting the other player.
So that is definitely a consideration that has come across our minds, but we did not think too hard about that given the use case of our current player base being the amount of devs. So it was a very low priority that we did not get to. You can only you can only use an emote every 3 seconds anyways, but you can keep using it just in that case. It becomes a term of just trust in the other player, not using it way too much, though sometimes you might want to do that. So it's a somewhat of a tricky basis because you might want to do that and sometimes you might not want to do that. It matters if the friend you're playing with doesn't like you or not.
So
we leave it up to that.
Alka asks, will your opponent be able to view the spider trap on their end, or is it hidden from them?
Yeah, the trap is actually viewable on their end. All state of the field is viewable to both players, because otherwise it would get a bit more confusing than it would need to. It would become a game it would become a little too difficult of tactics to keep track of. So we made the traps just visible to both of them. So it sort of works as, instead of a trap, it works as being something that your opponent now has to evaluate if it's worth it or not to go on that space and get trapped during that turn. Because comparable to the stink bug's ability, which blocks out a space, the trap berry is very easy to power up. It's a lot cheaper to power up. So also webs are visible in real, they're kind of visible when you look at a web. So we weren't thinking about it being like an underground mine trap. Then we just think about like laying the spidey web kind of thing.
So Noah asked about the art and design process and also what the inspiration for the bug theme came from.
So art and design, that's an interesting one. This game, I definitely already went through the process of where this game has started out with clouds, then hamster toasters, then bugs. So the bugs actually came from a different game, which was one of the propositions in this for this class called Adventure Ants. Adventure Ants was going to be a RPG game. However, it unfortunately did not make it when the final cut happened, just because of the nature of the scope of an RPG being too much. So when the final cuts for the teams happened, we inherited Julius and his amazing adventure ants. So we decided, you know what, this might be a great way to go for our characters. When we're instead of the hamster toasters, we figured that the ants and the bugs would give a lot more uniqueness and a lot more fun and, well, relatability to a lot of the characters to be able to use them, especially in a game where you're moving around small pieces. Using small insects seems a lot more appropriate. Let's see how it came about, how we went about going through each of these characters. We went going every sprint or so, we thought of like a couple more characters to add in here. And then we're like, okay, what does that type of character generally do? What do you know that character for? You know stink bugs for stinking. So we were like, okay, let's make a stink trap type of thing. So as well as other things where we know praying mantises are aggressive. So let's make that praying mantis go and directly punch the player. And okay, it's not as violent as I said, but directly attacks the player in a different way that is a lot more aggressive than your usual attack scheme. So we went hand in hand of developing the characters iteratively throughout and based on their characteristics as we saw them.
So there were a couple other questions about paper prototyping. Did you do prototyping?
Oh yeah, prototyping was big. Prototyping was a huge part of this process here. We were sitting down with poker chips on a cardboard mat.
Oh yeah, that was just stage one.
That was stage one of the paper prototyping.
We had like a whole sprint based on fun.
Oh yeah, the first sprint was entirely dedicated to designing the game, period. We didn't even know what we're kind of getting into with the rules and stuff. And we wanted to make sure that it was a balanced game that was actually fun to play. And we found that we were like keeping that as high top priority. So we spent a lot of time trying to figure out different combinations. We went through, could we do this like chess where different pieces move different amounts? Could we do this like a couple other considerations? We made like, let's pair up all the units up to 4 stacking like a totem pole and move it fast. And we found out just if we try going as close to the core of checkers as possible, but tweening it just enough to make it exciting, while yet players still know how to play checkers too, that it's not unfamiliar, we could make a really good game. And we've tested, not only playing it in private playtest sessions ourselves, but also showing it to friends and having them get feedback. A lot of this game has been a bunch of testing, because there's really not much when you're saying, oh wow, I made checkers for my 493 project. But it's been a lot of testing to see what works, what doesn't, and what is fun and what is not. And it has been not only just the paper prototype, paper prototype evolved into Google Jamboards, where we moved around pieces on the internet. That was definitely a big consideration when we had online classes. It was definitely hard to paper prototype when you can't use paper, and you got people all across Maryland developing and building on this game. I will say that it was a little easier when I had Brandon to test with in person, because I can always test any game on him in person. But we had to adapt our paper prototyping strategy, and it was interesting, and I definitely think it worked out in the end.
So Brett asks for you to, why did you choose to use Godot?
Godot, so Brandon and I both have a history of using a lot of Godot. We've been using Godot in club games for the UMBC Game Developers Club. I'm the current acting president of the UMBC Game Developers Club, moving out of the school as I'm graduating this year. Brandon's also an officer position, and we've both been actively invested in Godot. After visiting, the Unreal, we visited Unity, I visited Game Maker and all of the games. Godot seems to be the most friendly to starting out a new game and adding new art assets, as well as great with 2D heavy games, because 2D heavy games, Godot has a separate 2D rendering pipeline, which turned out to actually bite us in the back
I was going to ask if Brandon still thinks that after his
yeah. I will say this was a
Godot
special.
4.0 is coming with the Vulkan renderer, and everything will be solved.
Okay, but it has been great with like any person's first game engine to start in is very nice, easy to get used to. And I gotta say the best system with Godot is their animation, their heavy animation player system, where like you make anything into an animation player. You don't have to worry about exactly how you're tweeting this or that.
Every one of these characters, even the jump, even moving them around, is actually just another animation. I just changed the start and end points. It's super easy to think about.
Not only that, but you can see all the VFX, all the UI elements using animations. Every one of these, we don't have these we don't want static images. We want as many animations as possible. And Godot just encourages that workflow. And it makes a really nice looking game without having to go too crazy deep into making animations by hand or too crazy deep into programmatically making the animations, just because it's very good with that.
So, and one more question, are you able to change the skins of your character?
So change the skins, like, are you talking about adding little hats, adding accessories, or changing the color?
Anything to change the look?
That was actually on our sprint log for something that we wanted to do in the final sprint. We thought about doing this from the very first day or so, or not first day, but once we started the bug type of appeal, we wanted to try to get in customizable colors, equipped items, etc. But we figured that was maybe a little too far out in the scope. Instead, we really hammered down hard on optimizing for performance, and it went very well.
Can I chime in on something with that? It's not really just the optimization that I'm really proud of where we are with this project, because no matter what, this is a game that you can give to someone, tell them very briefly how to play it, and within a matter of just a few minutes, actually really get into a fun game where everyone's going back and forth, and each person is trying to find out what is the optimal character combination. Even if you're the one who made the characters themselves, there's always some new thing. So the point we're at now, where we can just play these games, have 8 solid characters to choose from, I wouldn't have it any other way.
So there's 2 questions for the artists, and these should probably be our last 2 questions of the night. What was the process of designing the characters themselves? How did you handle the balance of work for the visuals? And did you have a backstory for each bug?
So I designed the bugs based on, like, I actually thought of the power-ups first and then came up with the bug. Like, for one, one power-up I thought of was like a boost, like more spaces. So I was like, okay, which bug would go fast? But then I decided to make a pun, and I named the ability Ladies First, and I gave it to the ladybug. Other things, I just like bugs in general, and so I picked some I liked. Some of them are like, some I liked were like, spiders, mantises. Those are common, but they also I was also asked by the programmers to add like special things, like a character that can give gauge to everyone else. So that's what butterfly came from. A character can block a space, so that's where stink bug came from. And yeah, everything else I just like entomology stuff. So
regarding the backstory, do we have a backstory on the characters?
What's their lore?
I don't think we have went that far into making.
All right, so basically, very intelligent bugs wanted to play checkers in the backyard of some dude's yard, and then that's what happened. I guess.
And this was the onset of the Great Bug Territory War, which is resulted in many casualties of smushed bugs.
You can tell we've been very mechanics focused on this game and not quite into the lore as some that maybe more culturally inspired games might be. So yeah, we've been like just definitely hitting hard down on making a game and making a great experience.
All right. So before we presented today, we agreed that we wanted to show every bug. So Brandon took the top 4 and I took the bottom 4. I have now learned that butterfly and ant are top tier. I'm going to lose again. So yeah.
All right. Well, thanks to all of the teams, and huge thanks to our guests who came and watched this and asked questions. The video will remain up on YouTube if you want to share it around later. Although obviously, I'll have to reach directly out to the developers if you want to ask further questions. So thanks to everyone, and I think we'll call that a night.